And what happens when you wake up? You open your eyes. When you open your eyes, light comes into your eyes. Now, the way this system works is that you have a particular set of neurons in your eye. They're called retinal ganglion cells. You don't have to remember that if you don't want to. But these retinal ganglion cells are brain neurons. Again, the retina is just the one piece of your brain, actually two pieces because most of you have two retinas, that resides outside the skull per se. When light comes into the eye, there's a particular group of retinal ganglion cells or type of retinal ganglion cells that perceives a particular type of light and communicates that to this clock that resides right above the roof of your mouth called the suprachiasmatic nucleus. Okay? So I know this can get a little complicated, but these retinal ganglion cells, when you open your eyes, light comes in and an electrical signal is sent to this central clock we call the suprachiasmatic nucleus. And the suprachiasmatic nucleus has connections with essentially every cell and organ of your body. Now, it's vitally important that we get light communicated to this central clock in order to time the cortisol and melatonin properly. When I say properly, I can say that with confidence because we know, based on a lot of evidence, that if you don't get your cortisol and melatonin rhythms right, there are tremendously broad and bad effects on cardiovascular health, dementia, metabolic effects, learning, depression, dementia. In fact, there's so many negative effects associated with getting this wrong that I don't want to go into it in too much detail. In fact, I feel like we've been bombarded with all this information about how we're not sleeping well, we're not sleeping at the right times, we're not sleeping enough, to the point where people now have sleep anxiety. They if they can't sleep well for a night, they're feeling overwhelmed by that, and it's sort of now they're stressed about not being able to sleep, which is making it harder to sleep, et cetera. I really want to focus on what we can do to anchor these systems properly. So let's think about what happens when we do this correctly and how to do it correctly. When we wake up, our eyes open. Now, if we're in a dark room, there isn't enough light to trigger the correct timing of this cortisol melatonin thing, these rhythms. You might say, well, why won't any light do it? Well, it turns out that these neurons in our eye that set the circadian clock and then allow our circadian clock to set all the clocks of all the cells and organs and tissues of our body responds best to a particular quality of light and amount of light. And those are the qualities of light and amount of light that come from sunlight. So these neurons, what they're really looking for, although they don't have a mind of their own, is the sun at what we call low solar angle. The eye and the nervous system don't know anything about sunrises or sunsets. It only knows the quality of light that comes in when the sun is low in the sky. The system evolved so that when the sun is low in the sky, there's a particular contrast between yellows and blues that triggers the activation of these cells. So if you wake up and you look at your phone or your computer or you flip on a bunch of artificial lights, will these cells be activated? And the answer is sort of. They'll be activated, but not in the optimal way. What you want to do is get sunlight in your eyes as close to waking as possible. Now, I want to be really clear about this because I've talked about it on other podcasts when I was a guest, and I've talked about it on my Instagram feed, and there seem to be the same questions coming up again and again. These neurons don't know sunlight per se. They don't know sunrise or sunset for that matter. They don't know artificial light from sunlight. What they respond best to, however, is the quality and amount of light that comes in when the sun is low in the sky. That means that if you can watch the sunrise, great. That's perfect for triggering activation of these cells. However, if you wake up a few hours after the sunrise, which I tend to most days personally, you still want to get outside and view sunlight. You don't need the sunlight beaming you directly in the eyes. There's a lot of photons, light energy, that's scattered from sunlight at this time. But the key is to get that light energy from sunlight, ideally, into your eyes. Now, I know many of you are already asking, well, I live in Scandinavia, or I can't get sunlight. There's buildings around me, etc. We will get to all of that. But it's critically important that you get outside to get this light. I had a discussion with a colleague of mine, Dr. Jamie Zeitzer, who's in the Department of Psychiatry and Behavioral Sciences at Stanford, a world expert in this. And he tells me that it's 50 times less effective to view this sunlight through a window, through a car windshield, or through a side window of a car than it is to just get outside with no sunglasses and view light early in the day. Now, if you can't see the sunrise, like I said, you can see this within an hour or two of sunrise, but it has to be low solar angle. Once the sun is overhead, the quality of light shifts so that you miss this opportunity to time the cortisol pulse. And that turns out to be a bad thing to do. You really want to time that cortisol pulse properly, because we'll get into this a little bit more later, but a late shifted cortisol pulse, in particular a 9 p.m. or 8 p.m. increase in cortisol, is one of the consequences and maybe one of the causes of a lot of anxiety disorders and depression. So it's kind of a chicken egg thing. We don't know whether or not it's correlated with, it's the cause or the effect, but it's a signature of depression and anxiety disorder. Bringing that cortisol pulse earlier in your wakeful period, earlier in your day, has positive benefits ranging from blood pressure to mental health, etc. I'm not going to list them all off because there's just so many of them, but many, many positive things happen when you are getting the cortisol early in the day, far away from your melatonin pulse. Okay, so how long should you be outside? Well, this is going to vary tremendously because some people live in environments where it's very bright. So let's say it's Colorado in the middle of winter, there's a snow field, there's no cloud cover, and you walk outside, there's going to be so much photon light energy arriving on your retina that it probably only takes 30 to 60 seconds to trigger the central clock and set your cortisol and melatonin rhythms properly and get everything lined up nicely. Whereas if you're in Scandinavia in the depths of winter and you wake up at 5 a.m. and the sun is just barely creeping across the horizon and then goes back down again a few hours later, you probably are not getting enough sunlight in order to set these rhythms. So many people find that they need to use sunlight simulators in the form of particular lights that were designed to simulate sunlight. However, I'm not out to attack the companies that produce those. There's another solution to that. You can simply go outside for longer. Even if there's a lot of dense cloud cover, you're probably getting anywhere from 10,000 to 50,000 lux, L-U-X, which is just a measure of light energy. And that should be sufficient to set the circadian clock. You could say, well, the lights in my house or my phone are really, really bright, right? Everyone's telling us to stay off our phones at night because they're really bright. But guess what? It turns out that early in the day, your retina is not very sensitive, which means you need a lot of photons, ideally coming from sunlight, to set these clock mechanisms. So looking at your phone or artificial lights is fine if you wake up before sunrise, but it's not going to work to set these clock mechanisms. And this is supported by dozens, if not hundreds, of quality peer-reviewed studies. So you want to use sunlight. If you can't see sunlight because of your environment, then you are going to have to opt for artificial light. And in that case, you're going to want an artificial light that either simulates sunlight or has a lot of blue light. Now, without going off course here, you might be saying, wait, I've heard blue light is bad for me. Actually, blue light is great for this mechanism during the day. We can talk about blue light and blue blockers, but you really want a lot of blue and yellow light arriving on the retina early in the day. Let me be clear about something. You never, ever want to look at any light, sunlight or artificial light, that is painful to look at. If you find that your eyes are watering or you're having challenges maintaining, looking at this thing for a while because it's painful, that light is too bright and you do not want to damage your retina. So you don't want to gaze at the sun, refusing to blink and burn your retina. That's actually possible to do. You don't want to do that. You have a proper blink reflex installed in you since birth, and if you feel like something's too bright and you need to blink, it means you need to blink, that it's too much light. So please don't beam your eyes with really bright light. But blue light, in particular blue light and yellow light coming from sunlight, is ideal. If you're going to get it from artificial light because you can't get enough sunlight, well then artificial lights that are rich in blue wavelengths are going to be ideal for setting this mechanism. A lot of people will say, I should be wearing blue blockers throughout the day. No, that's the exact wrong thing. If you're going to use blue blockers, we can talk about that. That should be reserved for late in the evening because light suppresses melatonin. I've been asked many times before about this pineal gland, and there are a lot of ancient practices that map to some of the things that I'm saying, and people always say, oh, I heard that sunlight is great for the pineal. Well, perhaps, but we have to be careful about that phrase. Sunlight inhibits the pineal. It prevents it from releasing melatonin. Darkness allows the pineal to release melatonin. So the pineal is not the gland or the organ of sunlight. It is the gland of darkness. In fact, melatonin can be thought of as a sleepiness signal that's correlated with darkness. So get up each morning, try and get outside. I know that can be challenging for people, but anywhere from 2 to 10 minutes of sunlight exposure is going to work well for most people. And you want to do this on a regular basis. And you don't have to do it exactly at sunrise. I realize I'm repeating myself, but somehow, despite barking at people about this for a couple years now, I keep getting the same questions. And somehow it hasn't been sinking in, which could be related to some circadian disorder. I'm just kidding. If it's not sinking in, it's probably that I'm not being effective in communicating the information. But get that bright light early in the day from sunlight. And if you can't get it from sunlight, get it from artificial light. What kinds of artificial lights will work? Well, there are these sunrise simulators, but the ring lights that people use for selfies and this sort of thing, for posting on Instagram, those generate a lot of blue light. If you want to get experimental about this, there's a free app. I have no relationship to the app, but it's a great app called Light Meter that you can use your phone and you can measure the amount of photon energy in your environment. And it's kind of a fun experiment to do. You can go outside in the morning and you'll see that there's 10,000, 20,000 lux, even though it might seem like it's kind of dim or there's tree cover or cloud cover. You go inside and you shine that an artificial light at your phone, press the button on Light Meter, and you'll find that it's only 500 or 1,000 lux. And you realize that even though it seems really bright, the artificial light is very condensed, whereas the outside light is scattered in the atmosphere. And so you can think that you're not getting much sunlight, but you're actually getting much more outside. So get outside, get that sunlight early in the day, and try and do it on a consistent basis. If you can't do it every day or you sleep through this period of the early day, low solar angle, don't worry about it. These systems in the body, these hormone systems and neurotransmitter systems that make you awake at certain periods of the day and sleepy at other times are operating by averaging when you view the brightest light. Now, that can immediately tell us that what most people are doing is terrible. They're waking up and they're looking at their phone, which isn't triggering activation of these cells in the eye and the central circadian clock. Then a few hours later, they might get in their car with sunglasses and drive. Now, a note about sunglasses and prescription lenses. Absolutely never, ever, ever compromise safety for the sorts of things I'm talking about. So if you need to wear sunglasses for safety reasons, wear them. Absolutely, if you wear prescription lenses or contacts, wear them. They won't filter out the wavelengths of light that are necessary for setting these central clocks. So safety first, of course. If you have a retinal degenerative disorder, retinitis pigmentosa, macular degeneration, or glaucoma, or those run in your family, you want to avoid excessively bright light all the time. You want to be very cautious about that. You're going to want to get your light exposure through seeing dimmer light, including sunlight, but for longer periods of time, perhaps. You might immediately ask, what about low vision or blind people? How do they set these central clocks? Well, turns out that low vision and blind people, most of them, provided they still have eyes, that the eyes weren't removed because of a burn or tumor or something like that, still maintain these neurons that set the circadian clock, which brings me to a really important point. It's not about seeing and perceiving the sun. This is a subconscious mechanism by which these neurons, which are called melanopsin ganglion cells, these neurons set your central clocks by getting activated by the particular wavelengths of light that are present in the atmosphere, even coming through cloud cover. And you don't need to see or perceive the sun in order to get this mechanism to start.